Generally, it is not recommended to install receptacles directly above hydronic floorboard heaters due to several reasons. The heat generated by the heaters can damage receptacles, wires, and other electrical components. The high current draw of the heaters can overload circuits, especially if multiple receptacles are nearby. Overheated receptacles and wires pose a safety hazard and can lead to electrical fires. The National Electrical Code, also known as NEC, does not specifically address the placement of receptacles above hydronic floorboard heaters. However, it does provide general guidelines for receptacle placement and safety. Receptacles should be installed at least 12 inches above the finished floor, according to NEC section 404.9. Receptacles should not be installed in areas where they are likely to be exposed to moisture or heat, according to NEC section 406.8a. To ensure safety and prevent potential issues, it is best to avoid installing receptacles directly above hydronic floorboard heaters. If necessary, consider these alternatives. Firstly, relocate receptacles to areas that are not directly above the heaters. Secondly, install floor boxes with recessed receptacles to avoid direct contact with the heat. Thirdly, consider using high-temperature receptacles that are rated for higher temperatures. Ensure that electrical wiring and components are adequately sized and rated for the load of the heaters. Use ground fault circuit interrupter, or GFCI, outlets in areas that may be exposed to moisture. Regularly inspect receptacles and wiring above heaters for any signs of heat damage or overheating. When dealing with electrical installations near hydronic floorboard heaters, several factors must be considered to ensure safety and compliance with the National Electrical Code. While the NEC does not explicitly prohibit installing receptacles above hydronic heaters, it provides general guidelines that, when interpreted, strongly discourage such placement due to potential hazards. The primary concern is heat damage. Hydronic floorboard heaters, as their name suggests, radiate heat, and this heat can have detrimental effects on electrical components such as receptacles and wiring. Continuous exposure to elevated temperatures can degrade the insulation of wires, leading to short circuits, ground faults, and ultimately, electrical fires. Receptacles themselves can warp or melt, compromising their ability to securely hold plugs and increasing the risk of electrical shock. Another significant issue is circuit overloading. Hydronic heaters often draw a substantial amount of current, and if receptacles are installed nearby and used simultaneously, the circuit can easily become overloaded. Overloading can cause breakers to trip frequently, which is inconvenient, but more seriously, it can lead to overheating of the wiring and the potential for fires if the breaker fails to trip. To mitigate these risks, the NEC provides several relevant guidelines. Section 404.9 mandates that receptacles be installed at least 12 inches above the finished floor. While this requirement is not directly aimed at hydronic heaters, it indirectly helps to keep receptacles away from the immediate vicinity of floor-mounted heaters, reducing their exposure to heat. Section 406.8 prohibits installing receptacles in locations where they are likely to be exposed to moisture or heat. This is a more direct guideline against placing receptacles above hydronic heaters, as these areas are prone to higher temperatures. In practical terms, several alternative solutions can be employed to avoid placing receptacles directly above hydronic heaters. Relocating receptacles is the most straightforward approach. By moving the receptacles to a nearby wall that is not directly above the heater, you can significantly reduce the risk of heat damage and overloading. If relocation is not feasible, consider using floor boxes with recessed receptacles. These boxes are designed to be installed in the floor and provide a secure and protected housing for the receptacle. Recessing the receptacle into the floor helps to minimize its exposure to heat from the heater. Another option is to use high-temperature receptacles. These receptacles are specifically designed to withstand higher temperatures than standard receptacles and are less likely to be damaged by the heat from the heater. However, even with high-temperature receptacles, it is still advisable to minimize their exposure to heat as much as possible. In addition to these measures, it is crucial to ensure that the electrical wiring and components are adequately sized and rated for the load of the heaters. This means using wires with a sufficient gauge to handle the current drawn by the heaters and ensuring that the circuit breaker is appropriately sized to protect the circuit from overloading. Ground fault circuit interrupter, or GFCI, outlet should be used in areas that may be exposed to moisture, such as bathrooms and kitchens. GFCI outlets are designed to detect ground faults, which can occur when electricity leaks from a circuit to ground, and to quickly shut off the power to prevent electrical shock. Finally, it is essential to regularly inspect receptacles and wiring above heaters for any signs of heat damage or overheating. Look for discoloration, melting, or other signs of damage. If any damage is detected, the receptacle or wiring should be replaced immediately. By following these guidelines and taking appropriate precautions, you can safely install receptacles near hydronic floorboard heaters and minimize the risk of electrical hazards. Remember, when in doubt, always consult with a qualified electrician to ensure that your electrical installations comply with all applicable codes and regulations. Let's further discuss some of the specific considerations and best practices for installing electrical receptacles in proximity to hydronic floorboard heaters, emphasizing safety and code compliance. Firstly, we should delve into the potential thermal impact of hydronic heaters on electrical components. Hydronic heaters work by circulating hot water through pipes or panels, radiating heat into the surrounding environment. While they generally produce a more consistent and less intense heat compared to electric resistance heaters, the continuous exposure to even moderate heat can still degrade electrical insulation over time. The insulation on electrical wires is typically made of thermoplastic materials, which can become brittle and crack when subjected to prolonged heat. This degradation can lead to short circuits, ground faults, and arcing, all of which pose significant fire hazard. Receptacles themselves are also vulnerable to heat damage. The plastic housings can warp, crack, or melt, exposing the internal components and increasing the risk of electrical shock. The metal contacts inside the receptacle can also corrode or lose the spring tension, making it difficult to securely hold plugs and creating a loose connection that can generate additional heat. Given these potential thermal impacts, it is crucial to maintain a safe distance between receptacles and hydronic heaters. As previously mentioned, NEC Section 404.9 requires receptacles to be installed at least 12 inches above the finished floor. This requirement provides a minimum buffer zone, but it may not be sufficient in all cases, especially if the heater is particularly powerful or if the receptacle is located in a poorly ventilated area. In addition to the 12-inch rule, consider the specific layout of the room and the positioning of the heater. If the heater is located near a corner or in an alcove, the heat may be more concentrated in that area. In such cases, it may be necessary to increase the distance between the receptacle and the heater or to provide additional ventilation to dissipate the heat. Another important consideration is the type of receptacle being used. Standard receptacles are typically rated for a maximum operating temperature of 75 degrees Celsius or 167 degrees Fahrenheit. While this temperature is generally sufficient for most residential applications, it may not be adequate in close proximity to a hydronic heater. High-temperature receptacles are available that are rated for higher operating temperatures, typically up to 105 degrees Celsius or 221 degrees Fahrenheit. These receptacles are designed to withstand the heat from appliances such as ovens and stoves, and they can also be used near hydronic heaters to provide an extra margin of safety. When using high-temperature receptacles, it is important to ensure that the wiring connected to the receptacle is also rated for the same temperature. Using standard wiring with a high-temperature receptacle can defeat the purpose of the receptacle and still lead to insulation degradation and potential hazards. The wire insulation should be marked with a temperature rating that is equal to or greater than the receptacle's rating. In some cases, it may be necessary to use a different type of wiring altogether, such as mineral insulated cable, which is highly resistant to heat and fire. Let's consider the installation of floor boxes with recessed receptacles. Floor boxes provide a convenient way to install receptacles in floor, but they can also create a potential fire hazard if not installed properly. The main concern is that the floor box can trap heat and moisture, creating a conducive environment for corrosion and insulation degradation. To mitigate this risk, it is important to choose a floor box that is specifically designed for use with receptacles. These boxes typically have a gasketed cover to prevent moisture from entering and are made of a non-combustible material such as metal. The floor box should also be properly grounded to prevent electrical shock. The receptacle should be recessed into the floor box to minimize its exposure to heat from the heater. The receptacle should also be installed in a way that allows for adequate ventilation to dissipate any heat that may accumulate inside the box. In addition to these installation considerations, it is also important to regularly inspect floor boxes for signs of damage or corrosion. The cover should be checked to ensure that it is properly sealed and that there are no cracks or gaps that could allow moisture to enter. The receptacle should be checked for signs of corrosion or overheating. If any damage is detected, the floor box or receptacle should be replaced immediately. Moving on to the electrical load considerations. Hydronic heaters can draw a significant amount of current, especially when they are first turned on. This can put a strain on the electrical circuit and potentially lead to overloading. To prevent overloading, it is important to ensure that the circuit is properly sized for the load of the heater and any other appliances that may be connected to the same circuit. The NEC provides guidelines for calculating the load of electrical circuits. These guidelines take into account the size of the heater, the voltage of the circuit, and the number of other appliances that are connected to the circuit. The circuit breaker should be sized to protect the circuit from overloading. The breaker should be rated for a current that is slightly higher than the calculated load of the circuit, but not so high that it would allow the wiring to overheat. It is also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the receptacle is lower than the voltage at the electrical panel. This can happen if the wiring is too long or too thin, or if the circuit is overloaded. Voltage drop can cause appliances to malfunction and can also increase the risk of overheating. The NEC provides guidelines for calculating voltage drop. These guidelines take into account the length of the wiring, the size of the wiring, and the load of the circuit. If the voltage drop is too high, it may be necessary to use larger wiring or to install a separate circuit for the heater. And lastly, let's address the ground fault circuit interrupter, or GFCI, protection. GFCI outlets are designed to protect against electrical shock. They work by detecting small imbalances in the current flowing through the circuit. If an imbalance is detected, the GFCI outlet will quickly shut off the power to prevent electrical shock. GFCI outlets are required in areas that may be exposed to moisture, such as bathrooms, kitchens, and outdoor locations. They are also recommended in areas where there is a risk of electrical shock, such as near hydronic heaters. When installing GFCI outlets near hydronic heaters, it is important to choose a GFCI outlet that is specifically designed for use in damp locations. These outlets are typically made of a corrosion-resistant material and have a gasketed cover to prevent moisture from entering. The GFCI outlet should also be properly grounded to ensure that it will function properly. The GFCI outlet should be tested regularly to ensure that it is working properly. The test button on the outlet should be pressed to simulate a ground fault. If the outlet trips, it is working properly. If the outlet does not trip, it should be replaced immediately. In summary, installing electrical receptacles near hydronic floorboard heaters requires careful consideration of several factors, including thermal impact, electrical load, and ground fault circuit interrupter, or GFCI, protection. By following the guidelines outlined in the NEC and taking appropriate precautions, you can ensure that your electrical installations are safe and code compliant.